Hello, it is Danica,
And Jordan.
and we are here to explain homework 9 for our Engineering 460 class. So the problem that we were presented with for homework 9 is the Monty Hall problem, which is kind of set up like you're on a game show. So in this game show, the scenario is that you have 3 doors to pick from, and the grand prize of a Lamborghini, let's say, is behind one of the doors, and you just need to pick the right door. So if you choose a door and the presenter or like the host opens another door showing that that second door is not correct, should you switch doors if given the option? That is the Monty Hall problem. So mathematically explaining this, in this scenario, each of the 3 doors has about a 33% chance of being the correct door. So let's say that we arbitrarily chose door 1. That's what we have decided to go with. And the announcer or the host is going to open door 3. So he opens it and we see that it's a goat. It is not the right door. It is not the grand prize. So when we have chosen door 1, each door has a 33% chance of being correct. So we chose door 1, that still has a 33% chance, but the other 2 doors combined have a 67% chance that one of them is going to be correct. But because the announcer already opened door 3 and showed us that that's not the grand prize, door 2 kind of takes on that 67%. And so our door still only has a 33% chance of being right, so we want to therefore switch doors. So that's kind of the mathematical approach, but let's talk about MATLAB really quick. Do a MATLAB simulation.
Okay.
Switching over to MATLAB here.
Okay. So for our MATLAB simulation, we are going to have n trials of a million, and what we're going to do is we're just going to generate the 3 doors problem. So there's the winning door, so Randy 3, so it could be 1, 2, or 3. And the initial door you pick could be 1, 2, or 3, and the door they open could be 1, 2, or 3. But we put this while statement in here to make sure that it's not the same as the win door, because they can only select a door that has the goats in it. So then after that, I just did the 3 cases possible. So they could pick door 1 for their initial, pick door 2 for their initial, and pick door 3 for initial. Under that, you would have, if the open door, the one that the guy opens, is 2, then your guess is 3 because that is the other one, and vice versa, that's 2. Do the same for the other ones, and then these statements right here are simply our recording statements for our probabilities. So let's say we run this. We should get...
I need to pull that up. Oh, if I can grab it, there we go.
Yeah, there we go. The same one that we got, 67% and 33%. So very, very similar to what we predicted mathematically. And with that, that's it.
All right, thanks guys.